The last bit of stoichiometry that we need to look at is we need to look at limiting reactants. With limiting reactants, it's a lot like a recipe as I started this whole stoichiometry off with. Let's say a recipe says that we need 2 cups of sugar, 2 eggs, and 3 cups of flour. And you can see the ingredients that we have in our inventory. The question is, what is keeping us from doubling this recipe? I mean, if it is going to make 36 and I need to make 72 cookies and I need to double this recipe, well, let's look there. 2 cups of sugar. 2 doubled is going to be 4 cups of sugar. And yes, indeed, I have 8 cups of sugar, so I have enough of that. Okay, let's look up here. 2 eggs. So if I'm going to double it, I need 4 eggs. But when you look over here, 3 eggs. And then the 3 cups of flour, that would be 6 cups, and of course I have 7 cups. The eggs are keeping me from completely doubling this recipe. And that's a lot like chemical reactions. You're not going to have the perfect amount of each one. There's going to be some that's going to be left over. You're going to have some that's going to be completely used up. Every single chemical reaction has a limiting and an excess reactant, with the exception of decomposition. Notice limiting reactant, excess reactant. That means I need 2 reactants, but when you think of a decomposition reactions only have 1 reactant. The limiting reactant, that is the one that gets completely used up in the chemical reaction. Okay, all of it's gone, none left over. The excess reactant, that's the one that you're going to have a little bit left over. I mean, you're not going to dump a whole bunch in. When you think of some of our stoichiometry questions that we've been doing, I've said, excess amount of this or excess amount of that. Well, now we're going to figure out, which one is truly the limiting and which one's going to have some left over. Your steps for limiting reactant, step number 1, you're going to balance the chemical equation, as always. Okay, number 2. And I started doing this a few years ago, and it actually is probably the best way to do it. But what you're going to do is you're going to convert from one of the givens to what the question is asking. Number 3, you're going to convert from the other given to what the question is asking. And then the last thing is choose the smaller of the 2 answers. Because obviously when I'm making something, the limiting reactant's going to always produce the smaller of the amounts. So let's look at this problem. It says here that we have a synthesis reaction. 12 grams of aluminum and 16 grams of sulfur. Part A, which one of those is the limiting reactant? Part B, which one is going to be the excess reactant? And C, how much aluminum sulfide is produced? And finally D, how much of that excess reactant is going to end up being left over? So let's go ahead and let's start looking at this sample problem. Remember, okay, number 1 says we need to balance this chemical equation. So balancing this chemical equation, we're going to probably need to put a 2 there and a 3 there. Okay, so that one's done. Number 2, it says to take one of the givens. Okay, and if you remember back here, it said we have 12 grams of aluminum and it said we had 16 grams of sulfur. And the question is, well, how much of that gets produced? Well, remember what I said. We're going to take one of these and go to aluminum sulfide. So I'm going to go ahead and start off. 12 grams of aluminum. 1 mole of aluminum weighs 27 grams. Next step is our mole to mole ratio. So 2 moles of aluminum is going to produce 1 mole of aluminum sulfide. And then the final step is we have to go to grams. So 1 mole of aluminum sulfide. When I add all of that up, I get 150.3 grams of Al2S3. When I run that through my calculator is going to tell me I get 33.4 grams of Al2S3. Okay, step number 2. Step 2 says, well, take your other given and run it to aluminum sulfide. So on that one, we'll go ahead and start off with 16 grams of sulfur. 1 mole of sulfur is 32.1 grams of sulfur. This one's going to have a mole ratio, 3 moles of sulfur to every 1 mole of Al2S3. And Al2S3 still has a mass of 150.3 grams. Al2S3. When I run that one through my calculator, I get 24.97 grams of Al2S3. So when I start thinking of the questions, okay, the first question said, which one is the limiting reactant? Is it the aluminum? Is it the sulfur? Well, back in my steps, I said choose the smaller of the two numbers. 24.97 is going to be less than the 33.4. So what that means is this one right here, sulfur. That's going to be my limiting reactant. And if that's my limiting reactant, then that must mean that aluminum is going to be my excess reactant. So, part A, limiting reactant, sulfur. Letter B says, well, which one's your excess reactant? Well, my excess reactant is going to end up being aluminum. Letter C says, how much product or how much aluminum sulfide got produced? And I told you the one that got produced is the smaller of the two amounts. So 24.97 grams of Al2S3. Part D said what I needed to do was tell me how much of my aluminum is left over. I'm now going to start off with my limiting reactant, which is going to be sulfur. And again, all chemical reactions proceed by the limiting reactant. So I'm going to start off with my 16 grams of sulfur. 1 mole of sulfur is going to be equal to 32.1 grams of sulfur. Again, from my balanced chemical equation, 3 moles of sulfur. Now, what I'm going to is now I need to find out how much aluminum's left over. Finding out how much aluminum's left over, we're now going to convert to aluminum. 1 mole of aluminum weighs 27 grams of aluminum. When I run that through my calculator, I get 8.97 grams of aluminum. That's 8.97 grams of aluminum gets used. But the question said, how much aluminum is left over? So if you remember back in the start, it said we had 12 grams of aluminum to start with. We're going to use 8.97 grams of aluminum. And when I run that through, I get an answer of 3.03 grams of aluminum. So in part D, how much aluminum is left over? 3.03 grams of aluminum.